what is the essence of life? What does every molecule, every cell need to survive? The answer? Energy. Hi, I'm Sukhjot, that's Dillon, and this is Collen, and today we're presenting to you a revolutionary idea. An idea that comes around once in a lifetime. An idea that will remove the market inefficiencies with how we consume energy. According to Roland Rosario, head of R&D at Vectren, there are 3 problematic concerns with the energy production in the state of Indiana today. The first is unpredictability behind high peak load energy consumption. Second is the inability to transition consumers' behaviors in consuming energy. And thirdly, it is the economic inefficiencies that arise from these 2 variables. Now, if we take a look at this graph and look at this area right here, this is demand peak time energy. So this is when supply exceeds demand, which causes dead weight loss. This is due to the fact supply is so high that energy companies cannot produce enough energy, so they have to buy energy from other utility companies at a premium cost. Now, if you take a look at this off the hours, this is the inverse. This is when supply is so low and energy production is too high, resulting in foregone producer loss.
Now, according to Roland Rosario, the holy grail to this problem is disaggregation. So what we're proposing is to create an application that leverages disaggregation in order to modify consumer behaviors and allow for time-of-use pricing structures for the utility company. How are we going to do this, though? Well, by applying sensors to the main fuse box of a home or a business, we're going to be able to track the amount of energy going into that home and what it is being used for. So with that kind of information, we're going to be able to create 2 different user interfaces. One's going to be for the utility company, where they're going to be able to see on a map where energy is being used, when it's being used, and then they can draw conclusions about why it's being used that way and what they can do to change that behavior. The other user interface is going to be for the consumer. They're going to be able to access it on their smartphone or their computer, and with that they're going to be able to see what's using energy in their house, when it's using energy in their house, and most importantly, when time-of-use pricing gets instituted, what it's costing them. So that way they're going to be able to make more efficient, more economic, and more environmentally friendly decisions with the way that they consume energy. So let's talk about time-of-use pricing a little bit. This chart here shows time of use, but before I get into that, I should establish what we're doing right now. The way it works right now is you pay a flat rate the whole time, no matter what the load is on the grid. It's just an average. They take an average of the demand curve, and that's what you're paying at any given time. Time of use pricing is different. It's a lot more unique. What they do is divide the day up into different segments, and they attach a different price tag to each segment based on the demand. And in doing so, it encourages people to use more energy during off-peak hours, which eliminates the dead weight loss that they're currently contending with. And this also provides a benefit to the user, because if they shift their behavior and they start using energy during an off-peak time, then they are lower than the average that they would otherwise be paying. So they're saving money right here. Of course, if they do not change their behavior and they use lots of energy during peak time, well, then they're going to see the other side of time-of-use pricing and hopefully take that as an indication to start making more efficient choices with the way that they consume energy.
Now, the electric industry is a $319 billion industry with 13.5% growth expected up until 2021. There are several market trends that are influencing the way we develop and solve this problem. With the demand for time-of-use pricing, more people want to be able to know what they're using and when they're using it. More demand for being able to integrate with your appliances and see what you're using here, what energy you're using with certain appliances and different HVAC systems in your house. There's also different government regulations now that are limiting how much energy can be produced with emissions from coal power plants and how those inefficiencies are being lost to and from different substations and to our customers, trying to reduce those. Now, there are 9 different power companies in Indiana that that equate for $9 billion of the $319 million in the industry, or billion. But we want to start by targeting the big four: Duke, Vectren, Indiana, Michigan, and Hoosier Electric. All of those different companies have their own territories, so they are a governmental monopoly.
So a question you may have is, how are we going to do this? In order to effectively articulate this to you, we devise a business model canvas that is going to articulate the value we provide, how we're going to deliver that value, and then in the next slide, because it wouldn't fit in the screen, how we're going to monetize this to ensure a sustainable business model in the long run. In order to understand the business model canvas, we need to take a look at this first section here, the value proposition. So for the end users, our value proposition is minimizing household energy costs through the disaggregation of individual appliances, allowing them to check their real-time energy consumption and adjust their behavior to certain price structures. And for utility companies, it'll be inverse. They'll be able to better predict users' time of use, energy consumption demands, altering consumers' behaviors, and allowing to better predict how much energy to produce at certain times of the day. Now, with this, we have a few key activities we need to do to ensure we can provide this value. The first is the installation of sensors. We need to install sensors on all fuse and breaker boxes across the region to be able to track this. Second is the development of a UI/UX system to provide a dashboard for the utility companies so they can effectively see this data, along for users so they can actually look at all their appliances and look back at past historical data to see how much they've improved. Following that, we do need UI/UX maintenance systems to ensure we provide the best value throughout the years. And thirdly is integration with the legacy systems legacy software systems that Vectren has. So they obviously have old software systems, and we need to integrate our new system with theirs. And in order to achieve these activities, we need key resources. The first is leverage Vectren's, like I said, Vectren's legacy systems. Second is sensors. Third is Katerra's backend system to power the disaggregation aspect of this. Cloud-based servers to track and store all the log data. And lastly, an app store to deliver this product.
Now we have two different customer segments that we want to target with this. First being our end users, the households and the businesses, so that they can monitor their data usage within their home or their business and see how they can better predict their usage. And then we also want to be able to do predictive analytics for Vectren so that they can better predict their time of use pricing, their peak loads or non-peak loads. And we want to be able to establish relationships with Vectren and with our customers by having a support team in place that we will train Vectren's field techs to be able to go out and work on these systems in the helm for our customers in the area. And we also want to have a troubleshooting team that will help them work through the app, any problems they're having, show them what they need to do or what they can do better, and then also in-app recommendations for you need to turn the lights off here, you can save energy by not using HVAC during this time of the day. Now, we want to be able to get this app out there. We got to use Vectren's channels, Vectren's social media, Vectren's commercials, whatever they already have in place. Let them know that, their customers know they have this software available, and you need to take advantage of it to save you money. And we also want to be able to use our own social media account, other social medias for different power companies that we're using, as well as local media, local commercials, local advertisers in the area for our viewer audience that will be participating with the app.
So in order to make sure that we're actually providing the value efficiently and effectively to the end user, we're going to need to look at a few key metrics. So what we're going to do is identify key performance indicators, the first of which is going to be power factor, which Mr. Rosario told us about. It's basically the efficiency of the electricity being delivered. And then aside from that, we're going to look at the histories of people's usage so that we can use predictive analytics and behavioral pattern recognition to make sure that what we're doing is providing a value and that people stay interested in using it. But so what are we going to do to make sure that we're actually going to be a sustainable company? Well, we've got a pretty basic cost structure with our fixed and our variable costs. Of course, it's the usual stuff: salary, rent, raw materials, and of course the 10% equity that Katerra is going to have in the venture, as well as all of our digital type expenses with data storage, building the UI, and all that kind of stuff. As far as revenue streams go, where we're actually making the money, we're going to be looking at $15, a one-time fee for the end user to pay to get this set up, and a $5 fee to the utility to go in there and get this set up. And then after that first initial fee, the end user is going to be paying $2 a month in order to keep the service going, and the utility is going to pay $5 a month per customer to keep the service going. So what does that look like? Well, with 142,000 customers, which is roughly the number that Vectren currently has using their system, looking at $20 up front, $7 recurring, we can see that it's going to be in the first year $2.8 million up front for the setup fees. Of course, that's only going to be in the first year. And then about $12 million per year in revenue. So the first year's total revenue is, of course, going to be about $14.7 million. Now our costs, on the other hand, are going to be raw materials, about $2.4 million. That's going to be for the sensors and the actual labor to go and set this up in people's homes. And then going from there, yearly salaries, it's going to be our IT team. We looked at what it's going to cost to have a 24-hour call service, IT guys, people that can handle the hardware. To keep a staff, it's going to be about $550,000 in salaries, no getting around it. Rent for a place, an actual office building and infrastructure is going to be $100,000 roughly, depending on where we end up putting it. And data storage is going to be $15,000 in order to rent that virtual space to store the data, which gives us the big final figure of about $10 million, about $9 million of which is ours, and $1 million of which is the Keter at 10% of about $1 million.
So in conclusion, we are minimizing household energy costs through disaggregation of individual appliances for end users. This will benefit utility companies by altering consumers' energy consumption patterns, in return reducing energy costs. Thank you.
All right.